Thank you very much, Mark. Good afternoon, everybody. As Mark said, my name is Martijn Flink. I'm the product sales specialist for Emerson Automation Solutions in the Benelux. And today I'd like to give you a quick overview about how selecting a different technology or a different valve can help you to reduce your fugitive emissions. So if we just have a quick overview about what are emissions, basically we can bring this down to 3 different types based on the source. We have combustion. So basically you have a fuel or a product, you burn it, you generate emissions. Another type of emission is intended venting. Let's say you have a tank, a system, you have an overpressure situation where you need to somehow reduce your pressure in a system, you intend to vent your media, emissions. The last part is fugitive emissions. Fugitive emissions are basically all your emissions, all your product loss that you don't actually intend to vent or to flare. Basically, fugitive emissions are a loss of product. Loss of product, loss of money, and in some cases, for example, let's say you have methane, most people can no longer simply vent to the atmosphere, they have to burn it, send it to a flare. So 1, you're venting your product, causing you money. 2, you're burning that product, generating CO2, for which you need to pay a CO2 tax. Let's have a quick look about a tank, a general tank top layout. This can be an API 620 tank, 650 tank, or an EN 14015. Just a very brief overview about the different types of equipment or valves you can find in your tank. This is by no means the complete list, it's just a very short general overview. We have, within the tank, a normal operating pressure. Basically, the pressure that your product is stored at. If you're going to pump your media into the tank, basically you have to push out the vapor at the top of the tank. This can be done either through a pressure relief valve or through a deep pad system. Let's say you have a tank with a padding system, so you put nitrogen in your tank, you want to recycle the nitrogen, you can use a deep pad valve to actually reuse and recycle that nitrogen. So on the other side, if you're actually pumping out your media in the tank, you're pulling a vacuum, and then either you have to put oxygen into the tank through a breather valve, or you have to use a padding valve to put nitrogen into your tank. The padding and depadding valve are not required. There are a lot of tanks in this world that do not have those systems. They can simply use oxygen or outside air to control the pressure in the tank. So these tanks will then generally just have the pressure vacuum relief valves installed. Pressure vacuum relief valves, we have a couple of examples here on the slide. 1 valve, 2 functions. If you pump in your media or you pump out your media, you have to control the pressure in your tank. You have to either put outside oxygen or outside air into your tank, or possibly nitrogen. Over here, we have an example with a flame arrestor underneath. Let's say you have a very highly flammable gas or flammable gas in your tank. Breather valves will always leak. You are always leaking a little bit of the process gas to atmosphere. If you were to have a spark or a lightning flash or something, you can generate a flame or an explosion which could propagate into your tank. A flame arrestor is there to stop that from happening, to protect your tank. Under normal operation, you will only use these valves: padding, depadding, pressure vacuum relief valves. If there is an emergency situation, like for example a fire case, where you have a tank filled with liquid, you generate a lot of heat, you generate a lot of vapor in your tank, you need a very quick release of a lot of media. You can also have emergency relief vents. This can be on your pressure only side, and sometimes, if the tank's really important, also on your vacuum side. So this is just a very quick, very small overview of a tank. You have your normal operating pressure, you've got your overpressure, where you can either use your depadding valve to remove nitrogen from the tank, or your pressure vacuum relief valve to reduce the pressure from the tank. Very basic overview. Today I'd like to give you a small overview of how selecting the right pressure relief valve can actually help you in reducing the emissions from your tank. Pressure vacuum relief valve in its most basic form is just a weight-loaded or weight-operated valve. You have one tank connection, you have the pressure side used to relieve your overpressure from the tank. You have the vacuum side to pull in air from the outside world. This valve uses the pressure inside the tank. It acts against the pallet, pushing upwards. You've got a certain amount of weight on your pallet, pushing downwards. And at a certain point, if the pressure in the tank gets high enough, the pallet is lifted upwards and pressure is vented to the atmosphere, or your media is vented to the atmosphere. Within this type of technology, we can actually differentiate between two different models. We have what's known as a modulating valve. Basically, this is the older technology. You've got a pallet or your nozzle, and it takes a long time for the valve to fully open. So you reach your set pressure when the valve is supposed to open. You start to vent your pressure, but it will take up to 60, 70, 80, maybe even 100% extra pressure, so higher tank pressure, before the valve will be in the fully open and flowing position. We also have what's known as the high capacity full lift type. This example over here. For that valve, we guarantee that it's fully open and flowing at 10% overpressure. So that means that if you have a tank and you have your pressure relief valve set at 10 millibar gauge, this first valve will be fully open and flowing between 17, 18, 19 millibar gauge, and the high capacity full lift valve will be fully open and flowing at 11 millibar gauge. Fast opening, fully flowing in a very short amount of pressure. We also have a completely different type of technology, pilot operated relief valve. In this case, we no longer use weights to keep the valve closed, but we actually use the process pressure. We have the process pressure acting on the bottom of the valve. Process pressure is taken through the pilot to the dome of the valve and also acting downwards. Area in the dome is roughly 30% bigger than the area underneath the valve. Force is pressure times area. Area stays the same, pressure goes up. The higher the pressure in the tank, the more the valve closes, the more it pushes down. There will not be any leakage in this valve type. Showing a quick graph of the valve opening and the benefits of the low overpressure. We have a certain set pressure when we want the valve to open and relieve the excess pressure. If we look at the very old modulating types, we have the set pressure, and it takes a long time before the valve is fully open and flowing. So basically, if you've got a design pressure of your tank, you need to set the valve well below that to ensure that the valve will be fully open, flowing, and relieving your pressure. High capacity full lift type. We know, we guarantee it's fully open and flowing with only 10% overpressure. So you set the valve and it will be open within a 10%. Set it at 10 bar gauge or 10 millibar gauge, it'll be open and flowing at 11 millibar gauge. Same with pilot operated relief valves. Because we use the process pressure to keep the valve closed, all we have to do is relieve the pressure from the dome. Then you have the system pressure acting on the bottom. There will not be any pressure in the top, and the valve will be completely open and flowing within a couple of percent. Why is this important? Why are these different types of technology important? Well, we can use this to actually reduce our emissions from a tank. If we look at this graph, we take the old modulating type. Let's say we have a tank, design pressure 20 millibar gauge. 20 millibar gauge, we have to be fully open, flowing, and venting our excess pressure. We have to set the old valve at roughly 10 millibar gauge. Then it will start to open, slowly, 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 opening more and more and more, until it's fully open and flowing at the design pressure of your tank. All the while, it's opening, it's relieving pressure, it's venting gas. You're creating emissions. If we use the high capacity full lift valve, we know it's fully open and flowing within 10%. So with the same 20 millibar gauge design pressure of your tank, you can set this valve at 18 millibar gauge. And you'll still be fully open and flowing at 20. This gives us a big area where we actually reduce emissions. If we go to the pilot operated valve, that one's bubble tight up to 98% set pressure. It will be fully open and flowing within a couple of percent. So there, we even have less emissions. we can set the valves higher, we can increase the pressure at which the valves open, thereby reducing the emissions. The valves will also close earlier because your pressure where it opens is a lot higher, so it will also close a lot earlier, so you'll reduce a lot of emissions in between. If you've got process media where, whether it's toxic or whether it's a very smelly component or maybe something dangerous, let's say it's ammonia, you do not want to vent that to atmosphere. You do not want the neighbors complaining. Choosing a different type of technology, like for example a pilot or a high capacity fuel lift, will reduce your emissions, will save you money, will save you complaints, and will save you fines. So we have the valves, we know that they operate, but when do they open and how much do they open? Well, within Emerson, we also have a large product portfolio of sensors and monitoring solutions. There are different ways to check whether your valve is open and flowing. In the most basic form, we can put a proximity switch on the valve. It can be wireless, it can be wired. Once the valve's opening, you'll get a signal into your control room. We can also add things like differential pressure sensors, which will give an indication when the pressure in the dome of a pilot differs from the pressure in the system, thereby that you know that the valve is open and flowing. We can also provide acoustic sensors. These are wireless, they can be attached to a pipe. If a valve is opening, it's flowing, it's generating an acoustic noise, that sensor will detect it and it will send a signal to the control room. All this information can come together into Plant Web Insight, for example, our program, which can be used to monitor all the different sensors and can tell you which valves are operating. Most of the time you'll find that the 80-20 rule applies. 20% of your valves or 20% of your components gives you 80% of your problems. You can use a monitoring system, like for example the wireless transmitter, to find those bad actors, to see what's going on, to see what's wrong, possibly change the valve type, change the technology, and then try to get the system up and running again. Choosing the right technology will save you money, and it will save you emissions, and it will be good for you, good for the environment, and good for the wallet. So I know this has been a very quick overview, but I hope that you understand that choosing a different technology type, choosing the right valve can actually help you in operating your plant better and more efficiently. And if there's any more questions or if you'd like more information, we'll be available at the stand, the Emerson stand, the rest of the day. Thank you very much.